Okay, let's call this Chapter 11, Part 2. And now that we understand a little bit about production, let's talk about how that shapes up in terms of costs. Because firms, in order to maximize profits, are of course looking to minimize costs. And even in deciding which Q is the correct quantity to produce, costs are going to hugely influence that. So we're going to go through fixed, variable, total, put them all into average form, and then we will look at MC, because of course everything so far has been about MB and MC. Okay, so let's talk about our costs in the most basic form, and we divide them up into fixed and variable costs. And fixed costs plus variable are going to equal total. So this basic mathematical relationship is one you should commit to memory. Fixed costs are any costs that do not vary with the level of output. So if you think back to our dog washing example from the last video, our rent that we would have to pay on our space every single month would be a fixed cost. Doesn't matter if we wash one dog or we wash 100. The landlord's going to want money either way. So anything that doesn't vary with the level of output is fixed, and anything that does vary is variable. So oftentimes, as you increase output, you are going to experience more and more costs. In our dog wash example, you could think about this as having to probably hire more employees in order to get those dogs washed, buy more supplies, all of these kinds of things. So total costs are really just a summation. You take your fixed, you add your variable on top of it, and you're going to get to total. Okay, so let's go ahead and let's graph those. Okay, so let's go ahead and graph our costs. Our fixed cost, since it doesn't vary with the level of output, is going to be a horizontal line, because it doesn't matter if we're making or we're washing 0 dogs or 1,000 dogs. Our landlord is going to want to keep getting paid for rent. We're going to have all of our taxes, our licenses, any of them that are fixed payments. Let's say it's $3,000 per month for all of those fixed payments. Fixed cost is going to consistently have that same value, 3,000. Now, as we decide that we're going to go ahead and wash more dogs, we're going to have to hire more labor. And so variable cost is going to start going up, and it usually goes up at a decreasing rate. And then after diminishing returns sets in, starts increasing at an increasing rate. So variable cost is oftentimes going to have a shape like this one. And of course, total cost is just a summation of the two of them. So at any given point, we just need to add on $3,000 on top of the variable costs. So we could take this amount here, and we could basically add on $3,000 here, and you'd have a total cost point. And you can continue to do that, and you would get a total cost curve. And it's of course going to be parallel to your vertical or your variable costs, but it's going to be $3,000 gap at any given Q between variable and total. Okay? Hopefully that helps you to see that. Now, we have to understand our fixed and our variable and our total costs. But in those simple forms, they're actually not that useful for graphing and firm analysis. So oftentimes what we're going to use are average versions of them. And average versions are just, costs, normal costs that are divided by a specific level of output. So if we make 100 units of output and we have a fixed cost of $3,000 and a variable cost of $2,000 at 100 units of output, then our average fixed cost is just our fixed cost divided by the quantity that we're making. And our average variable is just our variable divided by the quantity. Okay, so this is going to be mathematically how you would solve for these if you ever asked to calculate them. And of course, you can get average total cost by dividing total costs by quantity, or you can just take average variable plus average fixed, and adding the two of them together will get you to average total cost. Okay, so these averages are going to be quite useful. We're going to graph them on the next slide. Okay, so let's graph these. We're normally ever going to graph ATC and ABC, and the reason that's going to work that way is because if we have those two, we can always solve for AFC. AFC is going to be the vertical distance between those two. So, the average total cost curve and the average variable cost curve are going to be U-shaped. And the vertical distance between them is always going to be equal to the AFC. And this, of course, would be the AFC at this particular quantity. Now, since fixed costs never change, but we're obviously making more and more output, as we make more and more output, AFC, of course, is getting smaller and smaller. And these two curves actually are going to get closer and closer together. My drawing's kind of ugly, but they'll asymptotically approach zero. So, bookmark these in the back of your brain. They are going to be very, very useful when we start analyzing a firm and helping them decide which quantity they want to produce. Okay, one last thing. We need to talk about marginal cost because, of course, our golden rule is MV equals MC. And none of our curves so far are dealing with the MC. Good news is the MC is derivative of the total cost curve. It is essentially asking how much additional cost happens when I change output. Ideally, when I change output by 1. But you need calculus to be able to do that, so this equation will work for our class. The easy way to see it graphically is to see that whenever the total cost curve is positive, but it's getting flatter through like this region here, the MC curve is actually going to be going down. Still positive costs, adding on to what it costs you to make the product, but the cost per unit at that point is falling. Okay? Eventually, the total cost curve starts to increase and increase at an increasing rate. In other words, it starts getting steeper and steeper, like this green section. And when that's the case, you are going to see that the MC curve starts shooting up like this. That is always going to be the sort of general shape for the marginal cost curve under normal circumstances, and it's going to be hugely important for us later. The last thing I want to teach you about it is that it also has a specific relationship with your average total and average variable costs. Your average total cost is always going to be intersected at its minimum point by the MC, and that is also true of the average variable cost. The reason that's going to be the case is because if in fact the MC is lower than the average, it'll drag the average down, because if the next unit costs you less than your current average, whatever kind of cost you want to talk about, your ABC or ATC, then the average of course has to be falling. Once the MC gets above that curve, then obviously the next unit is going to cost you more than your current average, and it has to drag your averages up. This is kind of like having an 85 exam score. If you want your exam average to go up, the next exam has to be higher than an 85. It's the same thing here with costs, except for firms aren't interested in costs rising. This just happens to them because of the law of diminishing marginal returns in the short run. So we're good now. We've got all of our major cost curves taken care of in the short run. We'll go ahead and we'll talk about long run in the next installment.